Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC, this angle equals to 60 degrees, and we also know that BF equals to CF equals to DF equals to EF. Okay, and we know that the area of triangle BDF, this triangle, equals to 8 square units, and the area of triangle CEF, this triangle, equals to 15 square units. And we want to find out the area of the quadrilateral ADFE with the green color. Okay, so first of all we will define angle ABC as B, and we will define angle ACB as C, and actually we have a rule number 1 that states that the sum of the angles in a triangle is equals to 180 degrees. Okay, so rule number 1 states that in any triangle the sum of the three angles is equal to 180 degrees. I will read rule number 1 again. Rule number 1 states that in any triangle the sum of the three angles is equal to 180 degrees. So, and especially in triangle ABC, the big triangle, the sum of the angles is equal to 180 degrees, that is to say 60 degrees plus angle B plus angle C equals to 180 degrees according to rule number 1. So we can subtract 60 degrees from this equality, and we will get that B plus C, that will be equation number 1, B plus C equals to 180 degrees. Okay, P plus C equals to 180 degrees. And we have also rule number 2, that states that if we have triangle ABC that has two equal sides, if in this triangle ABC we know that side AB equals to side AC, AB equals to AC, then according to rule number 2, those two angles are also will be equal to each other. So according to rule number 2, angle B will be equal to angle C, or actually rule number 2 states that in front of equal sides in the triangle, there are equal angles. I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So according to rule number 2, we know it is given us the question that in triangle BDF, this triangle BF equals to DF. Okay, in triangle BDF, BF equals to DF, side BF equals to side DF, okay, so in triangle BDF, BF equals to DF, and in front of side DF of triangle BDF we have angle beta. So in front of BF there must be also same angle according to rule number 2, because in front of equal sides in the triangle there are equal angles, and those two angles are located in front of equal sides in triangle BDF, therefore they are also must be equal to each other. So if this angle is beta, then this angle must be also equal to beta. Okay, so angle BDF equals to beta, and also in triangle FEC, this triangle, we know that FC equals to FE. it has given us in the question that FC equals to FE. So according to rule number 2 that states that in front of equal sides in the triangle there are equal angles, in front of EF we have angle C, and we know that FE equals to FC, so in front of FC we must have the same size of angle, that is to say this angle that is in front of FC must be also equal to C. So this angle is C, because of the fact that in front of equal sides there are equal angles. We know that FC equals to FE in triangle EFC, therefore those two angles that are located in front of equal sides in triangle FEC must be also equal to each other. Therefore, if this angle is C, this angle must be also equal to C. Okay? So, in the next step, we will define angle BFD as P, and we will also define angle C or EFC as Q. And again we will use the rule that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle BDF equals to 180 degrees. So in triangle BDF, the sum of the angles is equal to 180 degrees. That is to say, beta plus P equals to 180 degrees according to rule number 1. So beta plus beta is 2 beta plus P equals to 180 degrees. Okay, so again, this equality is according to the rule that states that the sum of the angles, rule number 1, the sum of the angles in any triangle is equals to 180 degrees. Okay, therefore in triangle BDF, the sum of the angles is equal to 180 degrees. That is to say, beta plus P equals to 180 degrees. So here we will subtract 2B from this equality, and we will get that P equals to 180 degrees minus 2B and we will use the same rule in triangle EFC. So in triangle EFC, we know that the sum of the angles in triangle EFC equals to 180 degrees. That is to say, C plus Q equals to 180 degrees. C plus C is 2C plus Q equals to 180 degrees according to rule number 1. Again, in triangle EFC, according to rule number 1, 2C plus Q equals to 180 degrees. Here we will subtract from this equality 2C, and we will get that Q equals to 180 degrees minus 2c. Okay, so actually we know also that P equals to 180 degrees minus 2b. Okay, so we found out the values of Q and P. In the next step we will add Q and P, we will add Q to P and in both sides of the equation, so we will get that Q plus P equals to, that will be equation number 2, Q plus P equals to 180 degrees plus 180 degrees is 360 degrees minus 2c plus minus 2b minus 2b minus 2c minus 2b. So Q plus P equals to 360 degrees. Here we will take a common factor minus 2 from this expression, and in the brackets we will have B plus C. B plus C. Okay, we got this equality that states that Q plus P equals to 360 degrees minus 2 times P plus C. But we have already found out in equation number 1 that P plus C equals to 180 degrees, 120 degrees. According to equation number 1, B plus C equals to 120 degrees. Okay, we know that P plus C equals to 120 degrees. So we can substitute B plus C in equation number 2 by 120 degrees. And we will get that Q plus P equals to 360 degrees minus 2 times P plus C equals to 120 degrees. So we'll substitute B plus C by 120 degrees. So we got this equality. Q plus P equals to 360 degrees minus 2 times 120 degrees. 2 times 120 degrees is 240 degrees, so I will write it down. Q plus P equals to 360 degrees minus 240 degrees is 120 degrees. So we found out that Q plus P equals to 120 degrees, and we've already found out in equation number 1 that B plus C equals also to 120 degrees. Okay, you have these two equations that B plus C equals to 120 degrees and Q plus P also equals to 120 degrees. So in the next step we will find the size of angle EFD. Okay, we will find the size of angle EFD. The size of this angle, according to the rule that the sum of the angles on a straight line is equal to 180 degrees. So this will be actually rule number 3. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. The sum of the angles on a straight line is equal to 180 degrees I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So actually BC is a straight line. So according to rule number 3, at point F, the sum of the angles on a straight line BC must be equal to 180 degrees. So therefore angle P plus angle Q plus angle EFD must be equal to 180 degrees according to rule number 3. Again, if we relate to the straight line BF at point F, the sum of the angles must be equal to 180 degrees according to rule number 3. Therefore, angle P plus angle Q plus angle EFD must be equal to 180 degrees. Okay? P plus Q plus angle EFD must be equal to 180 degrees according to rule number 3. But from equation, this equation number 2, we know that Q plus P equals to 120 degrees, so we can substitute P plus Q by 120 degrees in this equality. We will get that 120 degrees plus angle EFD equals to 180 degrees. Here we will subtract 180 degrees from this equality and we will get that angle EFD equals to 180 degrees minus 120 degrees is 60 degrees. Okay, so angle EFD equals to 60 degrees. So this angle is 60 degrees. So in the next step, we will connect together points, we will join together points E and D by a straight line. If we look at triangle EFD, in triangle EFD, this triangle, we know that side DF of triangle EFD equals to side EF. DF equals to EF. Again, in triangle EFD, we know that side DF of the triangle equals to side EF. Okay, so we know that in front of equal sides in the triangle there are equal angles. So if we define the angle that is in front of FE as Y, then the angle that is in front of side DF of triangle DFE must be equal also to Y, because in front of equal sides in the triangle there are equal angles. So if this angle is Y, then this angle also must be equal to Y, because those two angles are located in front of equal sides, therefore they are also equal to each other. Okay, so, and we also know, according to rule number 1, the sum of the angles in any triangle equals to 180 degrees, and especially in triangle EFD, the sum of the angles is equal to 180 degrees. Therefore, 60 degrees plus y equals to 180 degrees. Okay, again, according to rule number 1, the sum of the angles in triangle DFE equals to 180 degrees. That is to say, 60 degrees plus 2y equals to 180 degrees. Here we will subtract 60 degrees from this equality, and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. Here we will divide this equality by 2, and we will get that angle Y equals to 60 degrees. Okay, so actually we have here equilateral triangle. Triangle DFE is an equilateral triangle because all its angles are equal to 60 degrees. This is 60 degrees, and angle FED also equals to 60 degrees, because we found out that Y equals to 60 degrees. Okay, and we also know that all the sides in an equilateral triangle are equal to each other, so side EF equals to side DF equals to side DE. So if we define, and we know that all those sides that I marked in by two lines are also equal to each other. So if we define BF as x, then FC will be also equal to x, FE will be also equal to x, and DF will be equal to x, and DE also will be equal to x. Okay, in the next step we will find out the size of angle ADE, and we will also find out the size of angle AED. Okay, so we'll find out the sizes of the two angles in triangles ADE. In triangle ADE. And again, we know that the sum of the angles on a straight line is equal to 180 degrees, and actually AB is a straight line, so if we focus at point D, then the sum of its angles at point D is equal to 180 degrees, so B plus 60 plus angle ADE must be equal to 180 degrees. So we can write that angle B plus 60 degrees plus angle ADE must be equal to 180 degrees. Okay, according to rule number 3. Okay, so P plus 60 degrees plus angle ADE must be equal to 180 degrees. So here we will subtract 60 degrees from this. Actually, I didn't wrote rule number 3, so I will write okay I wrote rule number 3 that states that the sum of the angles in a straight line is equal to 180 degrees. So according to rule number 3, the sum of the angles in triangle the sum of the angles on a straight line is equal to 180 degrees, so we'll subtract 60 degrees from this equality, and we will get that angle P plus angle ADE equals to 180 degrees. We'll subtract B from this equality, and we'll get that angle ADE is 120 degrees. Angle ADE equals to 120 degrees minus B. Okay, so we found out that angle ADE, this angle, equals to 120 degrees minus B. But we have already found out in equation number 1 that B plus C equals to 120 degrees. So if we subtract C from equation number 1, we will get that B equals to 120 degrees minus C. So here we have 120 degrees minus. Okay, here we will subtract C from this. We will subtract B from equation number 1, and we will get that C equals to 120 degrees minus B. Okay, C equals to 120 degrees minus B. So here we have 120 degrees minus B, and according to equation number 1, it equals to C. So it equals to C. So from this equality, we can derive that angle ADE equals to C. Okay, angle ADE equals to C. So we found out that angle AD equals to C. So we will repeat on the same process in order to find out the value of angle AED. Again, we know that the sum of the angles on a straight line is equal to 180 degrees, and AC is a straight line. So if we focus at point E, according to rule number 3, the sum of the angles must be equal to 180 degrees. That is to say, angle C plus 60 degrees plus angle AED must be equal to 180 degrees, according to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. Okay. So here we'll subtract 60 degrees and also C from this equality. We will get that angle AED equals to 180 degrees minus 60 degrees is 120 degrees minus C. Angle AED equals to 180 degrees minus C, and we have equation number 2 that states that B plus C equals to 120 degrees. So here we will subtract B from this equality, equation number 2, and we will get that actually we will subtract we'll subtract C from this equality, and we will get from equation number 2, we will get that B equals to 120 degrees minus C. So actually, according to equation number 2, 120 degrees minus C equals to B. So here 120 degrees minus C equals to B. So from this equality, we can derive that angle AED equals to B. Okay, angle AED equals to B. So angle AED equals to B. Actually, in this triangle AED, we have three angles. The first one is 60 degrees. Then we have angle B and angle C, exactly like the same angles like as in triangle ABC. Triangle ABC also has one angle that is 60 degrees and angle B and angle C. So we can write down that those two triangles, triangle AD is similar to triangle ABC. Okay, so we will make it now. We'll prove that triangle AED is similar to triangle ABC. So in triangles AED and ABC, angle AED in triangle AED equals to angle ABC in triangle ABC, and both those two angles are equal to beta. Okay, and also we know that angle ADE in triangle AED, angle AED, angle ADE in triangle AED equals to angle ACB in triangle ABC, and both those two angles are equal to C. Okay, so we found that those two triangles, triangle AD and triangle ABC, has two angles that are equal to each other, and actually angle BAC that equals to 60 degrees is a common angle. It belongs both to the small triangle AED, and it also belongs to the big triangle ABC. So angle A equals to angle A is a common angle. It is a common angle. It belongs to both triangles, triangle ADE and triangle ABC. Again, we actually proved that all the three angles of triangle ABC are equal to all the angles of triangle AD. Therefore, we actually proved that triangle ABC is similar to triangle AED. Okay, so triangle ABC is similar to triangle ADE according to angle similarity rule. Okay, triangle ABC is similar to triangle ADE according to angle similarity rule. When you prove that all the angles in one triangle are equal to all the angles in another triangle, then those two triangles are similar to each other according to angle similarity rule. So from the fact that those two triangles are similar to each other, we can actually say that the following relationship exists, and before I will present you the relationship between those two similar triangles, we have a rule. I will call it rule number 4. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square to the ratio to the square to the ratio to the square ratio of their corresponding sides. So I will read rule number 4 again. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of their corresponding sides. So according to rule number 4, the ratio between triangle ABC the ratio between the area of triangle ABC, actually that is the sign of the area of triangle ABC. Okay, the ratio between the area of triangle ABC to the area of triangle ADE is equal to the square ratio of their corresponding sides. So it is actually BC square over DE square. again, according to rule number 4, the ratio between the area of triangle ABC to the area of triangle ADE equals to the square ratio of their corresponding sides. That is to say, it equals to BC square over DE square. Okay? But what is the value of BC? BC equals to x plus x, BC equals to 2x. So BC square is 2x square over DE square. DE equals to x, so DE square is x square. So we got that 2x square over x square is 4x square over x square. That is actually equals to 4. 4x square over x square equals to 4. So the area of triangle ABC will be equal to 4 times the area of triangle ADE. Okay, I multiply this equality by the area of triangle ADE, so we got this equality that states that the area of triangle ABC is 4 times bigger than the area of triangle ADE. Okay, so in the next step we will find out the area of quadrilateral BDEC. So actually the area of quadrilateral BDEC is equal to the area of triangle ABC minus the area of triangle ADE. Again, the area of triangle ABC minus the area of the small triangle ADE exactly equals to the area of quadrilateral BDEC. Okay, so the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of the small triangle, triangle AED or ADE. Okay, again, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. So the area of quadrilateral BDEC equals to the area of triangle ABC, but we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. So it equals to 4 times the area of triangle ADE minus the area of triangle ADE so the area of quadrilateral BDEC equals to 4 times the area of triangle ADE minus 1 times the area of triangle ADE. 4 minus 1 is 3, so the area of triangle BDEC equals to 4 times the area of triangle ADE. BDEC, the area of triangle of quadrilateral BDEC equals to 3 times the area of triangle ADE. Okay, and we also know that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, I will add here that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, so in the next step I will present to you a new formula for calculating the area of any triangle. So if we have triangle ABC, so in this triangle ABC we know that the size of side AB is A and the size of side AC is B, and the angle between side AB and side AC of triangle ABC is theta. Then the area of triangle ABC will be equal to A times B times sinus theta over 2. Again, the area of triangle ABC equals to A times B times sinus theta over 2. The area of this triangle ABC equals to A times B times sinus theta over 2. Okay, so we will calculate the areas of triangles BDF and EFC according to this new formula for the area of the triangle. We know that the area of triangle EFC is 15 square units and the area of triangle BDF is 8 square units, but we want to present the formula for that area. Okay, so the area of triangle EFC is 15. We divided it by the area of triangle DBF, that is 8. Okay, so we divided the area of those two triangles, the areas of those two triangles, and now we will calculate the area of triangle EFC according to the new formula for the area of any triangle. According to this formula, the area of triangle BFC will be equal to x times sine q over 2. And then again the area of triangle EFC equals to x times sine q over 2. X times sine q over 2. And the area of the small triangle, the formula for the area of the small triangle will be also x times sine p over 2. Okay. The area of triangle DBF equals to x squared times sine p. P is the angle between those two, side DF and side BF triangle of the triangle. So we multiply the two sides by each other, and then we will multiply it by the angle between those two sides, and we will divide it by 2. That will be the area of the small triangle. So here we have actually x squared over 2 times sine q and in the denominator we have x squared over 2 times sine p, all equals to 15 over 8. Okay, so we got this equality. Here x squared over x squared is 1, so 2x squared over 2x squared is 1, 2x squared is cancelled, and we left only with sinus sine x over sine p equals to 15 over 8. Sine q over sine p equals to 15 over 8. Okay, but we have equation number 2 that states that p plus q equals to 180 degrees, 120 degrees. So from equation number 2, we know that q equals to 120 degrees minus p. So we can substitute q in this equality by 120 degrees minus p. So we will get that sine, instead of q, we will write down 120 degrees minus p over sine p equals to 15 over 8. Okay, so we got this equality that sine 120 degrees minus p over sine p equals to 15 over 8. Now we will use a trigonometric identity in order to find out, to calculate the value of sine 120 degrees minus p. The trigonometric identity of sine A minus B is equal to sine A cosine B. Minus sine B cosine A. Again, we'll use this trigonometric identity of sine A minus B in order to calculate the value of sine 120 degrees minus P. Sine A minus B equals to sine A cosine B minus sine B cosine A. So according to this trigonometric identity, we will calculate the value of sine 120 degrees minus P. It is equal to sine 120 degrees times cosine P minus sine P cosine 120 degrees. Okay, and sine 120 degrees is root 3 over 2 times cosine P minus sine P, and cosine 120 degrees is minus 1 over 2. Okay, so now we will substitute sine 120 degrees minus P by this expression. Our original equality was the sine 120 degrees minus P. It is equals to root 3 over 2 times cosine P over sine P and here minus and minus is plus sine, so it is 1 over 2 sine P over sine P. Sine P over sine P is 1. So in total we will get that root 3 over 2 cosine P over sine P is cotangent P plus 1 over 2 equals to 15 over 8. Okay, root 3 over 2 times cotangent P equals to plus 1 over 2 equals to 15 over 8. Here cotangent P equals to 1 over tangent P again we will use this trigonometric identity and we will substitute cotangent P by 1 over tangent P. And we will get that root 3 over 2 times tangent P plus 1 over 2 is 4 over 8, that equals to 15 over 8. Okay, so here we will subtract from this equality 4 over 8 and we will get that root 3 over 2 times tangent P equals to 15 over 8 minus 4 over 8 is 11 over 8. Okay. Fifteen minus 4 is 11. So here we will multiply this equality by tangent P. Okay, we multiply this equality by tangent P. Here we will multiply this equality by 8 and then we will divide it by 11 in order to get the value of tangent P. Okay, so tangent P will be equal to 8 times root 3 over 2 times 11. Okay, we found out that tangent P equals to 8 times root 3 over 2 times 11. 8 over 2 is 4, so I write it down. Tangent P equals to 4 times root 3 over 11. So we found out the value of tangent P. Tangent P equals to 4 times root 3 over 11. As you already know, tangents is the relationship between the sides in a right triangle. So if we have a right triangle with angle P tangent P is the relationship between the angle that is in front, the side that is in front of angle P, and we know that this side is equal to 4 times root 3 divided by the size of the side near angle P, that is actually 11. Okay, here tangent P equals to 4 times root 3 over 11. But we want to find out the value of sine P, and in order to find out the value of sine P, we must calculate the value of the hypotenuse of this right triangle according to the Pythagorean theorem. that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, we will find out that the hypotenuse of this right triangle will be equal to the root of 4 times root 3 squared plus 11 squared. Okay? So actually sine P will be equal sine P will be equal to the side that is in front of angle P, that is 4 times root 3 over the size of the hypotenuse, that is root of 4 times root 3 squared is 48 plus 11 square is 121. So we found out that sine P equals to the root of sine P equals to 4 times root 3 over the root of 48 plus 121. 48 plus 121 is 169, and the root of 169 is 13. Okay, so sine P equals to 4 times root 3 over 13. We found out that sine P equals to 4 times root 3 over 13. Okay? So, actually, we know that the area of triangle BDF is 8 square units. So 8 square units equals to the area of triangle BDF, that is according to our new formula for the area of any triangle. The area of triangle BDF equals to x times x over sine P over 2. That is x squared times sine P over 2. Okay? Again, used the formula, the new formula that I presented to you, in order to calculate the area of triangle BDF. So we know that sine P equals to 4 times root 3 over 13, so we can substitute sine P in this equality by 4 times root 3 over 13, and we will get that 8 equals to x squared over 2, and sine P equals to 4 times root 3 over 13. Okay, so we got this equality. Here 4 over 2 is 2, so I write it down. 8 equals to x squared times 2 over 13 times root 3. So here we can divide this equality by 2, and we will get that 4 equals to x squared times root 3 over 13. Here we will multiply this equality by 13 and then we will divide it by root 3. We will get that x squared equals to 13 times 4 is 52 over root 3. We found out that x squared equals to 52 over root 3. Okay, in the next step we'll calculate the area of the equilateral triangle EFD. So the area of the equilateral triangle EFD, according to our new formula for the area of any triangle, it will be equal to x times x times sine 60 degrees over 2. Sine 60 degrees is root 3 over 2, and root 3 over 2 over 2 is root 3 over 4. So in total we got that the area of the equilateral triangle EFD equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3. Okay, so we can substitute x squared in this equality by 52 over root 3. And we will do it and we will find out that the area of triangle EFD will be equal to x squared is 52 over 3, or 52 over root 3 times root 3 over 4. Here root 3 over root 3 is 1, so root 3 is cancelled, and 52 over 4 is 13. So we found out that the area of the equilateral triangle EFD equals to 13 square units. Okay, so we can write here that the area of the equilateral triangle EFD equals to 13 square units. Okay, so actually now we can calculate the area of the quadrilateral BDEC. The area of quadrilateral BDEC equals to the area of triangle BFD, that is 8 square units, plus the area of the equilateral EFD, that is 13 square units, plus the area of triangle EFC, that is 15 square units. Okay, so the area of the equilateral BDEC equals to 13, 8 plus 13 is 21, as 21 plus 15 is 36. So we found out that the area of the equilateral BDEC equals to 36 square units. Okay, but we have already found out that the area of the equilateral BDEC equals to 3 times the area of triangle ADE. The area of the equilateral BDEC BDEC, the area of the quadrilateral BDEC equals 3 times the area of triangle ADE. Okay, the area of the quadrilateral BDEC equals to 3 times the area of triangle ADE. But we have already found out that the area of quadrilateral BDEC equals to 36 square units. So the 36 equals to 3 times the area of triangle ADE. So here we divide this equality by 3 and we will get that the area of triangle ADE equals to 36 over 3 is 12 square units. Equals to 12 square units. So the area of the green shape equals to the sum of the areas of the two triangles, to the equilateral triangle DEF and the triangle ADE. So the area of the green shape, that is actually AD, or the area of the quadrilateral ADFE, equals to the area of triangle AD, that is 12, plus the area of the equilateral triangle EDF, that is 13 square units. So 12 plus 13 equals to 25 square units. So the final answer to the question is that the area of the green shape, that is the green quadrilateral ADFE, equals to 25 square units. The area of this green quadrilateral equals to 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green quadrilateral ADEF, and we know that angle BAC of triangle ABC equals to 60 degrees, and we know also that BF equals to CF equals to DF equals to EF, and we also know that triangle BDF equals to 8 square units, and triangle CF, in the area of triangle CEF equals to 15 square units. And we want to find out the area of the green quadrilateral ADEF. Okay. First of all, we define angle ABC as B and angle ACB as C, and then we used the rule that states that the sum of the angles in any triangle is equal to 180 degrees. number 1 states that in any triangle, the sum of its angles, the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle ABC, the sum of its angles is 180 degrees, that is to say 60 degrees plus angle B plus angle C equals to 180 degrees. This is equation number 1. We subtracted 60 degrees from equation number 1 and we got that B plus C equals to 120 degrees. Okay, then we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So if AB equals to AC, then angle B equals also to angle C. Okay, again, rule number 2 states that in front of equal sides in the triangle there are equal angles. Okay, so actually if you look at triangle BDF, in triangle BDF, this triangle, we know that DF equals to BF, DF equals to BF, and in front of DF we have angle B. So in front of DF we must have the same angle. So if this angle is B, this angle must be equal also to B. Okay, and then we focused on triangle EFC. We know that EF equals to FC, and according to rule number 2, in front of equal sides there are equal angles. So in front of side EF we have angle C, so in front of side FC there must be same angle. So if this angle is C, this angle must be also equal to C, because of the fact that in front of equal sides there are equal angles. Those two angles are located in front of equal sides in the triangle, therefore they also must be equal to each other. So if this angle is C, this angle is also must be equal to C. Okay, so then we define angle DFB as P and angle EFC as Q, and we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle BDF, the sum of its angles is equal to 180 degrees. Therefore, beta plus P equals to 180 degrees. That is to say, 2B plus P equals to 180 degrees. So we subtracted 2B from this equality and we got that P equals to 180 degrees minus 2B. Then the same thing is true in triangle EFC. The sum of its angles is equal to 180 degrees, so C plus Q equals to 180 degrees, or 2C plus Q equals to 180 degrees. So we subtracted 2C from this equality and we got that Q equals to 180 degrees minus 2C, and we have already found out that P equals to 180 degrees minus 2B. So we added P to Q and we found out that P plus Q equals to 120 degrees, and B plus C also equals to 120 degrees. Okay, then we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. So actually here BC is a straight line. BC is a straight line, so at point F the sum of the angles on the straight line BC is equal to 180 degrees. So P plus angle DFE plus angle Q must be equal to 180 degrees. Again, P plus Q plus angle EFD equals to 180 degrees according to rule number 3. Okay? But we know that P plus Q, we found out that P plus Q equals to 120 degrees, so we can substitute P plus Q by 120 degrees. Okay? So from this equality, we got that angle EFD equals to 60 degrees. Angle EFD, this angle is equal to 60 degrees. So we know that in triangle EFD, the sum of its angles is equal to 180 degrees. And we also know that angle E, side EF equals to side DF. And according to the rule that in front of equal sides in the triangle there are equal angles, those two angles are equal to each other. So if this angle Y, this angle is also Y. And according to the rule that the sum of the angles in any triangle is equal to 180 degrees, so in triangle EFD, 60 degrees plus Y equals to 180 degrees. 60 degrees plus 2Y equals to 180 degrees. Here we subtracted 60 degrees from this equality. We got that 2Y equals to 120 degrees. We divided this equality by 2 and we found out that Y equals to 60 degrees. So this angle equals to 60 degrees and this angle also equals to 60 degrees. Actually, triangle EFD is an equilateral triangle. Okay, in the next step, and therefore all its sides are equal to each other, all its sides are equal to x. In the next step we found out the sizes of these two angles according to the rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. So angle side AB is a straight line. At point D, the sum of the angles is on the straight line AB is equal to 180 degrees. So C plus B plus 60 degrees plus angle EDA equals to 180 degrees. Again, angle B plus 60 degrees plus angle ADE equals to 180 degrees. Okay, here we subtracted 60 degrees from this equality, and in the end we got that angle ADE equals to C. Okay, and again we repeated on the same process on this side. We know that AC is a straight line, therefore the sum of the angles at point E is equal to 180 degrees. Therefore C plus 60 degrees plus the size of this angle is equal to 180 degrees. Okay, again C plus 60 degrees plus angle AED equals to 180 degrees because AC is a straight line and the sum of the angles on a straight line is equal to 180 degrees. Okay, so we solved this simple equation and we found out that angle AED equals to B. So we actually can see that those two triangles, triangle AAED is similar to triangle ABC because they have exactly the same angles, 60 degrees, B and C. The same angles we have in triangle ABC. So triangle ABC is similar to triangle AED according to angle similarity. And we have rule number 4 that states that the ratio between the areas of similar triangles is equal to the square ratio of their corresponding sides. That is to say, the ratio between the area of triangle ABC to the area of triangle ADE that are similar to each other is equals to the square ratio of their corresponding sides, and their corresponding sides are actually BC and DE, so it is equal to BC square over DE square, and we know that BC equals to x plus x and DE equals to x, so it is actually 2x square over x square is 4. So we found out that the area of triangle ABC is 4 times the area of triangle ADE. Okay, and then we calculated the area of the quadrilateral BDEC. The area of this quadrilateral is the area of triangle ABC minus the area of this triangle. So the area of triangle BD, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. But we have already found out that the area of triangle ABC is 4 times the area of triangle ADE. Okay, so we found that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE, and we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay? And then I presented to you a new formula for calculating the area of any triangle. The area of this triangle equals to A times B times sinus theta over 2. And the area of this triangle is 15 square units and the area of this triangle is 8 square units. So 15 over 8 equals 15 is the area of this triangle that is actually equals to, according to the formula that I presented to you, it equals to x times sinus q over 2. Okay, it equals to x times sinus q over 2. And the area of this triangle, triangle DBF, equals to x times sine p over 2. Okay, x times sine p over 2. Okay, so then we found out that sine q over sine p equals to 15 over 8. We know that p plus q equals to 120 degrees, so q equals to 120 degrees minus p. So we can substitute q by 120 degrees minus p. We substitute q by 120 degrees minus p and we got this equality. And we calculated the value of sine 120 degrees minus p according to the trigonometric identity that sine a minus b equals to sine a cosine b minus sine b times cosine a, and we use this trigonometric identity in order to calculate the value of sine 120 degrees minus p. Then we substituted sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p. We put it in the original equality, that sine 120 degrees minus p over sine p equals to 15 over 8. And we found out that cotangles actually tangents p equals to 4 times root 3 over 11. And then we calculated the value of sine p. Sine p equals to 4 times root 3 over the hypotenuse. So we found out that sine p equals to 4 times root 3 over 13. And then we know that the area of triangle BDF equals to 8 square units. And the area of the triangle, according to the new formula that I presented to you, is x times sine p over 2. Okay, it is x squared times sine p over 2. And we have already found out that sine p equals to 4 times root 3 over 13. Okay, so we put the value of sine p in this equality, and we found out that x squared equals to 52 over root 3. Okay, and then we calculated the area of the equilateral triangle EDF. The area of triangle EDF equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over 3. So we can substitute x squared by its value, 52 over root 3. We substituted x squared by this value, and we found out that the area of the equilateral triangle EFD equals to 13 square units. So after we found out that the area of the equilateral triangle equals to 13 square units, we actually know that the area of the quadrilateral BDEC equals to 8 plus 13 plus 15, that is 36. So the area of the equilateral triangle, the area of the quadrilateral EDEC equals to 36 square units. But we have already found out that the area of the equilateral, the area of the quadrilateral BDEC equals to 3 times the area of triangle ADE. And we also know that it is equal to 36 square units. So we have this equality that 36 equals to 3 times the area of triangle ADE. We can divide this equality by 3, and we found that the area of triangle ADE equals to 12 units. So the area of the green shape equals to the area of this triangle ADE, plus the area of the equilateral triangle EDF. That is to say, it equals to 12 plus 13, that is actually 25 square units. So the area of the quadrilateral ADEF, the green quadrilateral ADEF, equals to 25 square units. Okay, thank you very much.